Welcome back, everybody. Today we're going to be diving deep into the fascinating world of micrometers.
Ooh, very nice.
Maybe you're getting ready for a lab, or you're polishing up on your measurement techniques,
Yeah.
or maybe you're just curious about these little instruments and how they work.
Absolutely.
We'll be looking at excerpts from Open Educational Resources, Open Source Physics at Singapore,
Okay.
and specifically their micrometer app.
All right.
I really like that they have this interactive model.
Yeah.
It really helps you visualize how these things actually work.
I agree.
So let's start with the basics.
Okay.
What is a micrometer? What are we even talking about?
Well, in the most simple terms, it's a tool for measuring very small distances,
Okay.
like a hundredth of a millimeter, even smaller.
Oh, wow.
Yeah. But how it achieves that level of precision, that's where the magic lies.
So the source mentions the screw principle, which sounds interesting.
Yeah,
Could you break that down a little bit?
absolutely. So imagine a screw with very fine threads. Each time you turn that screw, it's going to move forward or backward a tiny but very precise distance.
Mm-hmm.
And we call that movement the lead of the screw.
Okay.
So a micrometer very cleverly utilizes this principle to translate that rotation
Yeah.
of a thimble into a measurable linear movement of a spindle.
So we're turning this thimble,
Yes.
and that's moving the spindle closer to or further from another surface.
Precisely. And that other surface is called the anvil,
Okay.
and that's fixed.
Gotcha.
It gives you a reference point for your measurement.
So that object we're measuring is going to be right between that spindle and that anvil.
That's right.
It's starting to come together.
Good.
So the source also mentions a constant lead.
Yes.
Why is that so important for accuracy?
Well, a constant lead means that for every full rotation of the thimble,
Okay.
the spindle is moving the exact same distance.
So it's consistent.
Exactly. And that's what makes the micrometer so accurate.
I see.
It's kind of like, a gear system.
Hmm.
One turn of a large gear might translate into several turns of a smaller gear, effectively amplifying that movement.
Okay.
And similarly with the micrometer, the small blade of the screw
Yeah.
amplifies the tiny rotation of the thimble into a measurable linear movement,
That's cool.
allowing us to measure those very tiny distances.
Like a built-in amplifier almost.
Yeah, exactly.
Now, the source also goes into describing the different parts of a micrometer in a lot of detail.
Yes.
We have the frame, the anvil, sleeve, spindle, and thimble.
Right.
It's almost helpful to try to visualize these things as we talk about them.
Yeah, visualization is definitely helpful.
Yeah.
So imagine you're holding a micrometer.
Okay.
You've got this C-shaped frame. It's very sturdy.
Mm-hmm.
And on one side, you've got the anvil.
Yeah.
It's a smooth surface. That's where your object rests.
Okay.
You've got the spindle attached to the screw mechanism
Mm-hmm.
that moves towards the anvil.
Okay.
And wrapped around that screw is the sleeve. It's got a scale on it. That shows you the main measurement.
Okay.
And finally, you have the thimble,
Okay.
the part that you grip and turn.
Yeah.
And that has its own scale for those really fine readings.
Speaking of those readings,
Yeah,
I'm really interested to know how to read the scales on the sleeve and the thimble.
of course.
But first, let's talk about this online model that you mentioned.
Well, yeah.
You were saying it really helps to bring these concepts to life.
It's a great resource.
Yeah.
Not only does it represent visually all the parts we just talked about,
Okay.
but you can actually interact with them.
Oh. Ooh.
You can adjust the size of the virtual object you're measuring,
Wow.
control the spindle's movement.
Okay.
You can even simulate zero error.
Zero error.
Yeah.
That sounds a little ominous.
Yeah,
Does that mean the micrometer is messed up?
not necessarily.
Okay.
Even the most precise instruments can have tiny imperfections.
Yeah, I guess.
Zero error just refers to a slight offset in the reading when the spindle and anvil are actually touching. Like if your kitchen scale shows a small weight when it's empty,
I see.
it doesn't mean the scale's broken.
Right.
You just have to account for it in your measurements.
So zero error is really just taking into account those tiny little discrepancies
Exactly.
that might affect our reading.
Yeah.
And
And that's where the model simulating that zero error is so insightful.
Uh-huh.
You can actually experiment with introducing small offsets
Yeah.
and see how they affect that final measurement.
Okay.
It really highlights how important calibrating your micrometer is.
Right.
Understanding that difference between accuracy and precision.
That makes a lot of sense.
Yeah.
So before we dive into that model and explore zero error a little more,
Okay.
let's look at how to actually read a micrometer.
Okay.
I'm curious about those sleeve and thimble scales.
Yeah.
How do they work together to give us that precise measurement?
Well, it's like a two-part puzzle.
Okay.
The sleeve gives you the main reading in millimeters,
Oh.
and then the thimble provides those fractions that add up to that final measurement.
Okay, so our source gives this step-by-step example with a reading of 5.78 millimeters.
Right.
Could we maybe walk through that together?
Yeah.
I think it helped to really understand how that process works.
Absolutely. So let's imagine we're looking at this micrometer, and we've just taken a measurement.
Okay.
First, focus on that sleeve scale.
Perfect.
You'll notice it's divided into millimeters.
Uh-huh.
Longer marks for the whole millimeters.
Gotcha.
And shorter marks for the half millimeters.
Okay.
Now, you want to find the last whole millimeter mark that you can see before the thimble edge.
Okay.
In this case, that would be the 5 foot.
Okay, so we've got 5 millimeters right off the bat.
Exactly.
5 millimeters.
Now, we check if the next half millimeter mark is also visible.
Okay.
And in our case, it is,
It is.
adding another 0.5 millimeters to our total.
Okay.
So far, we're at 5.5 millimeters.
So we know from the sleeve that we're at least at 5.5 millimeters. How do we get those hundredths of a millimeter from the thimble?
Yeah, that's where the thimble scale comes in. It
Okay.
usually has 50 or 100 divisions around its circumference.
Okay.
And you need to find the thimble marking that perfectly aligns with the horizontal datum line on the sleeve.
Okay.
That line acts as our reference point.
So going back to the 5.78 millimeter example,
Yeah.
the source says that thimble reading is 28.
Right.
How does that translate into those hundredths of a millimeter?
Well, each mark on the thimble represents 0.01 millimeters if there are 100 divisions,
Okay.
or 0.02 millimeters for a 50-division thimble.
Gotcha.
In our case, with a reading of 28,
Mm-hmm.
we'd multiply 28 by 0.01, which gives us 0.28 millimeters.
I see. So we add that 0.28 millimeters from the thimble to the 5.5 millimeters from the sleeve.
Right.
And we have our 5.78 millimeters.
Exactly. It's just understanding how those two scales work together
Right.
to give you that accurate reading.
Now, the source also mentions that this online model lets us practice reading the micrometer with different measurements.
Yeah.
And even with that zero error factored in,
It does.
that sounds really helpful.
It's great for building your skills.
Yeah, getting some hands-on experience without even needing an actual micrometer.
That's right.
Speaking of hands-on experience, I can't help but think about how these micrometers are used in the real world.
Yeah.
They must be pretty important for a lot of fields.
Oh, absolutely. Think of any scenario where you need to measure very small objects or distances
Uh-huh.
with extreme accuracy.
Right.
Manufacturing, for example,
Okay.
relies heavily on micrometers for quality control.
Right.
Imagine a factory making those tiny little components for electronics.
Yeah.
They need to make sure each part meets those exact specifications.
Yeah. Otherwise, things would go wrong.
Otherwise, the whole thing could malfunction.
Right. I remember reading that micrometers are super important in the aerospace industry, too.
Oh, definitely.
Building something as complex as a rocket engine,
Yeah.
you got to be really precise.
You need incredible precision.
So micrometers are used a lot to make sure every component,
Yes.
from those tiny valves to those big fuel tanks,
Right.
meet the right dimensions for it to actually work safely.
Exactly.
It's amazing how this seemingly simple tool
I know, right?
is so important for all this high-stakes stuff.
It is.
And now, thanks to this deep dive,
Yeah.
our listener knows enough to really appreciate how those applications actually work.
Indeed. And it's interesting that the micrometer hasn't really changed much
Oh, really?
since it was invented in the 19th century.
Wow.
Of course, we do have digital micrometers now,
Right.
which do have some advantages, speed and readability.
You're right. The source did mention digital micrometers.
Yeah.
I wonder if they work the same way as these mechanical ones.
That's a great question.
Yeah.
While they might look and feel different,
Uh-huh.
at their core, those digital micrometers still rely on that screw principle and that precise relationship between rotation and linear movement.
So they're just translating that movement into a digital display
And yeah,
instead of having to
right.
read those scales.
That's right.
So it doesn't matter if it's a classic mechanical micrometer or a new fancy digital one.
Right.
The basic principles are the same.
Exactly.
It's so cool how this centuries-old invention is still relevant and essential today.
It's amazing. It's a testament to how well designed the tool is
Yeah.
and to the ingenuity of the people who first used that screw principle
Right.
to unlock that level of precision
I agree.
in measurement.
We've covered a lot of ground today.
We have.
We went from the basics
Yeah.
to real-world applications.
Right.
And we even touched on how the micrometer has evolved.
Uh-huh.
Before we wrap up, is there anything else you'd like to highlight for our listener?
I think we've given them a great foundation to build on.
Okay.
Now it's their turn to go out and explore.
What do you mean?
Maybe research the history of the micrometer. Or compare the pros and cons of mechanical versus digital.
Okay.
They could even try using a real micrometer themselves
Yeah.
and feel that tactile feedback that we were talking about.
Those are great suggestions. I love that this deep dive has sort of opened up all these different avenues for further learning. It's
Exactly.
like we've given them a key to a whole new world of measurement.
Exactly. And who knows, maybe this deep dive will
Yeah.
spark an interest
Uh-huh.
that leads them to a career in engineering or science or something we haven't even thought of yet.
I love that.
Yeah.
So to recap for our listener,
Okay.
we started with what is a micrometer?
Right.
We talked about its design.
Based on that screw principle.
Yeah, the screw principle,
The concept of a constant lead.
which gives us all that precision.
Exactly.
We even looked at the different parts,
Yeah.
the frame, the anvil, the sleeve, the thimble,
Yes.
how they all work together to produce that accurate measurement.
We did.
We also tackled zero error,
Yeah.
highlighting how important calibration is.
And understanding that difference between accuracy and precision.
Exactly. And of course, we can't forget all those real-world applications.
Yeah, those are important.
Micrometers are crucial in manufacturing, aerospace, scientific research.
Right, all these fields where getting a precise measurement is really important.
Exactly. We even talked about how the micrometer has changed over time
Yes.
from those early mechanical ones.
To the modern digital versions.
But the fundamentals are still the same.
They are.
It's a story of ingenuity and precision.
And lasting impact.
Yeah, and a story that's still going on
Yeah.
as micrometers are being used in new ways and new fields all the time.
That's right.
And now our listener knows enough to understand and appreciate that story.
Yeah.
Maybe even contribute to it.
Perhaps they'll design the next generation of micrometers.
Or use them to make some big discoveries.
I love it.
The possibilities are endless.
They are.
That's the best part about knowledge, right?
Absolutely.
It opens doors to new ways of thinking and new adventures.
I couldn't agree more. Yeah, it's like a two-part puzzle, really.
Okay.
The sleeve gives you that main reading in millimeters,
Uh-huh.
and the thimble gives you those fractions of millimeters to get to that super precise measurement.
Okay. Our source has this step-by-step example for a 5.78 millimeter reading.
Right.
Maybe we could walk through that.
Sure.
I think that would really help to understand the process.
Yeah, so let's say we're looking at this micrometer. We just took a measurement.
Okay.
So first we focus on that sleeve scale.
All right.
You'll see it's divided into millimeters.
Uh-huh.
Longer marks for the whole millimeters.
Gotcha.
And shorter marks for the half millimeter.
Okay.
So you want to find the last whole millimeter mark that's visible before the edge of the thimble.
Okay.
And in this example, that would be the 5.
Okay, so we have 5 millimeters right there.
Exactly.
From the get-go, 5 millimeters.
Now we check to see if we can see the next half millimeter mark.
Okay.
And in this case, we can.
We can.
So we had another 0.5 millimeters.
Okay.
So now we're at 5.5 millimeters.
All right, so we know we're at least at 5.5 millimeters just from the sleeve.
Right.
So how do we use the thimble to get to those hundredths of a millimeter?
So that's where the thimble scale comes in. Usually it'll have like 50 or 100 divisions around the edge.
All right.
And you have to find the marking on the thimble that lines up perfectly with the horizontal datum line on the sleeve.
All right.
And that line is our reference point.
So back to our 5.78 millimeter example.
Yeah.
The source says the thimble reading is 28.
Okay.
How do we turn that into hundredths of a millimeter?
Well, each mark on the thimble represents 0.01 millimeters if it has 100 divisions,
Okay.
or 0.02 millimeters if it has 50.
Okay.
And since our reading is 28,
Yeah.
we multiply that 28 by 0.01 to get 0.28 millimeters.
So we add that 0.28 millimeters from the thimble to the 5.5 millimeters we got from the sleeve,
Exactly.
and boom, 5.78 millimeters.
You got it. It's all about understanding how those two scales work together
Right.
to give you that really accurate reading.
Now, the source also mentioned that we can use this online model
Yeah.
to practice reading different measurements on the micrometer.
Right.
And even with that zero error factored in,
You can't.
that sounds pretty useful.
It's a great way to practice.
Yeah, like getting hands-on experience without even needing the actual physical micrometer.
Exactly.
So speaking of hands-on experience, I can't help but think about all the ways micrometers are used in the real world.
Yeah.
I mean, they must be pretty essential to a lot of different fields.
Oh, yeah, definitely. Anytime you need to measure a really tiny object or really tiny distance with a lot of accuracy,
Okay.
you'll probably need a micrometer.
Like what?
Well, for example, in manufacturing,
Okay.
they use micrometers all the time for quality control.
Right.
So let's say there's a factory making those tiny components for electronics.
Yeah, like for a computer or a phone or something.
Exactly. And they have to be sure that every single part is the exact right size.
Right. Or else it won't work.
Right. The whole device could malfunction.
Now that I think about it, I remember reading that micrometers are used a lot in aerospace, too.
Oh, absolutely.
Building something as complex as a rocket engine,
Yeah.
you need insane levels of precision.
Incredible precision.
So they use micrometers a lot to make sure all those parts,
Right.
like the tiniest little valves and the giant fuel tanks,
Yeah.
are all the exact right size so it works safely.
That's exactly right.
It's kind of wild how this tool seems so simple,
I know.
but it's so important for all this crazy high-stakes stuff.
It is.
So thanks to our deep dive today, our listeners can really understand how important these applications are.
And how they actually work.
Yeah, and it's interesting the source mentioned that the micrometer hasn't really changed that much
Yeah, it's true.
since it was invented way back in the 19th century.
Yeah.
Of course, now we have digital micrometers,
Right.
but the basic idea is still the same.
Yeah, those digital micrometers have some advantages.
Okay, like what?
They're faster and easier to read.
Makes sense. You know, the source did mention digital micrometers.
Yeah.
I wonder if they work the same way as the mechanical ones.
That's a good question.
Yeah.
So they might look different and feel different,
Uh-huh.
but those digital micrometers still use the screw principle.
Okay.
That same exact relationship between turning it and moving that spindle.
So instead of reading those scales,
Right.
it just shows up on a digital display.
Exactly.
So no matter if it's a classic mechanical micrometer
Yeah.
or a fancy new digital one,
Right.
the basic idea is still the same.
The fundamentals are the same.
It's amazing that something invented so long ago
I know.
is still relevant and so essential
It is.
in today's world.
And that's a testament to just how well designed it is
Uh-huh.
and how smart those people were who first figured out how to use the screw principle
Right.
to get that level of precision.
I totally agree.
Yeah.
I feel like we've covered a lot of ground today.
We have.
We talked about how micrometers work,
Yeah.
how they're used in the real world.
Right. And even how they've evolved over time.
We did.
Is there anything else you want to point out to our listeners before we wrap up?
I think we've given them a really good foundation.
Okay.
Now it's time for them to do some exploring on their own.
Oh, okay. What do you mean?
Well, they could research the history of the micrometer a bit more,
Okay.
or maybe compare mechanical versus digital and see the pros and cons of each.
Yeah.
Or even try using a real micrometer themselves
Okay.
and get a feel for that tactile feedback we talked about.
I really like those suggestions. I love how this deep dive has opened up so many different ways to keep learning. It's like we've given them the key to this whole secret world of super precise measurement.
I like that, yeah. And who knows, maybe this deep dive
Yeah.
will spark somebody's interest and they'll end up
Yeah.
with a career in engineering or science
Yeah.
or something totally new that we haven't even thought of.
That'd be awesome.
Yeah.
So just to recap for our listener,
Yeah,
we started with what is a micrometer?
that's right.
We talked about how it works.
Yeah.
Yeah, all those clever parts.
That sprue principle,
The constant lead.
all that giving us that incredible precision.
It all comes together.
We even went over the different parts.
Yeah, like a little anatomy lesson.
The frame, anvil, sleeve, thimble.
All working together for that perfect measurement.
Yeah. And we even tackled zero error.
Oh, yeah, that tricky little thing.
But highlighting how important it is to calibrate your tools.
And understand the difference between accuracy and precision.
Right. Because they're not always the same thing.
Definitely not. And of course, we can't forget about all those real-world applications.
Right. Micrometers are essential in manufacturing,
Aerospace.
scientific research.
All these fields where getting that measurement exactly right is super important.
Couldn't have done it without the micrometer. And we even talked about how it's changed over time
From the old school mechanical ones.
to those fancy digital ones.
But the fundamentals haven't changed a bit.
It's a story of ingenuity
Precision.
and how something invented so long ago is still so important.
It's a story that's still unfolding, too.
Yeah, micrometers are finding new uses in new fields all the time.
That's the exciting part.
And now our listeners have the knowledge to appreciate all of that.
And maybe even be part of the next chapter.
Yeah, maybe they'll design the next generation of micrometers.
Or use them to make some amazing discovery.
It's all about those possibilities.
It really is.
I love how knowledge can do that.
Opens up a whole new world.
New ways of thinking, new adventures.
Couldn't agree more.
Well, thanks for joining us for this deep dive into the amazing world of micrometers.
It's been a pleasure.
We hope you enjoyed it and that you learned something new.
Absolutely.
Keep exploring, keep learning, and we'll see you next time.